This is the STM32. We used it to control the actual movements of the robot using two motors in the back and a servo motor in the front. Now we found that the robot would move slightly differently over different runs using the same settings because of slight differences in each wheel and the differences in the flooring that we were running on. So to correct for this, we had to implement a self-correction mechanism. And for that, we used the gyroscope present on the STM32 board in the ICM20948 IMU. Using the gyroscope, we corrected while going straight to align the robot to a perfectly straight line and while turning to make perfect 90-degree turns.
The STM board communicates with gyroscope through an I2C protocol. Besides the gyroscope, we employ two IR sensors to measure the distance and also avoid the car from hitting the obstacle. The ADC component will convert the voltage generated by the sensors into human-readable data.
For image recognition, we used YOLO V5 to train our model. Before training, we first labeled the images using label IMG. We needed to make sure that the bounding box tightly wrapped around the object entirely so that the model understands edges better. We manually labeled about 1.5K training images. Next, we used RoboFlow for preprocessing and training, which made it easier to automatically generate more image augmentations for robust training. The generated dataset is then split into training, validation, and testing sets. The model is then trained with 150 epochs. During image recognition, the images uploaded on the server are sent for inferencing, where the model, which is loaded using PyTorch Hub, runs on the image to obtain the labeled image ID. This image ID is then sent to RPy, while the raw image is displayed on the PC.
The algorithm acts as the brain of the robot by controlling how the robot moves. We assign 4 directions to allow the robot to traverse the arena. For path planning, we use exhaustive search to find all the paths to the obstacle. Next, we implemented A-style algorithm to find the shortest path from the list of paths. A cost model was also assigned to give a higher penalty for turns to ensure that the robot will prefer moving in straight lines. To ensure that there is sufficient space between obstacles, we augmented the obstacles to a 3x3 virtual obstacle, and the robot will only pass through if there is space between the virtual obstacle. Turning radius is also an important consideration for us. Non-reachable obstacles will then be abandoned such that the algorithm can continue to operate smoothly.
For the Android app, we envision it to be a minimalistic and functional app for usage and aim to develop the app as plug-and-play tool for users. On top of that, we designed it with considerations from the Android material design principles and the functionality of the user's experience while performing the task. We implemented the logic behind these components and merged them together to create a smooth user experience.
What we first thought of was the theme. We wanted the user to be presented with a simple and unique user interface. So we decided to embrace the red from the Raspberry Pi icon. We chose a light beige background to help contrast against a darker red to highlight the important buttons and text. We decided to separate the Bluetooth component and the grid map component to not overwhelm the user with information when he first enters the app.
The purpose of RPi is to enable communication between different components. To connect to the Bluetooth, we connect through Bluetooth socket. To connect to STM, we connect through USB port and connect through the relevant codes. To connect to the algorithm and sending of images for image recognition, we do it through requests, sending and receiving post calls through the IP address. The Raspberry Pi manages multi-threading of all communications, and to resolve the race condition, we implemented locks and queues to enable smooth communication between all components. The RPi also capture image using Pi camera with set configuration for pre-processing and send the image to server for image recognition. We made a backup using TensorLite in case of image taking too long to send through, or for YOLO V5 through Interpret.
Thank